So in this problem, we have two race cars, the Daytona 500, a Ford Thunderbird, and a Mercedes-Benz. So I'm just going to label them car 1 and car 2 for simplicity. So car 1 is moving at 71.5 meters per second, and car 2 is also traveling at 71.5 meters per second. And what they tell us is the driver of the Thunderbird realizes that she must make a pit stop, and she smoothly slows to a stop over a distance of 250 meters. So this is going to be the Thunderbird. Car number 2 is going to be the Thunderbird. What she does is she slows down, comes to a stop, comes to a pit stop, and takes a rest for 5 seconds, and then accelerates again back out of her rest to the velocity that she had before, which is 71.5. Now the whole time that this driver was slowing down, stopped, and then speeding up again, car number 1 just kept moving at 71.5 meters per second. So at the end of this, car number 1 is going to be ahead of car number 2. Does that make sense? And then what this question wants us to find, and then they also gave us these distances. The distance it took to slow down is 250 meters. And then after the rest stop, the distance to speed back up again is 350 meters. So putting a diagram down really helps a lot. I mean, trying to solve this problem without doing a diagram, I can't even imagine it, unless you have a really good ability to visualize things. But I've been teaching physics a long time, and when I do a problem like this, I always do a diagram. It just helps. All right, so what the problem wants us to do is figure out how far ahead car 1 is, how far ahead car 1 is compared to car 2. So car number 1 travels this distance, which we'll call, let's just call this x, and we're going to have to solve for this. What is this distance here? And once we know this distance, once we know how far car number 1 has traveled during this total time, then what we're looking to find is this distance in here, from here to here. This is what we're being asked to look for, that distance there, which we'll call, let's call this one x3, and this one's x4. So I call this is x1, x2, x3. The ultimate thing we're trying to find here is x4. So how are we going to go about finding x4? We're going to take x3, which is how far car number 1 travels, and we're going to subtract away x1 plus x2. Does that make sense? Okay, so how do we go about doing this? Well, the first thing we got to do is calculate what? Time. We need to figure out how much time goes by for car number 2 as she slows to a rest, and then as she speeds up again after resting. Okay? So we're going to focusing on car number 2, we're going to solve for T1. What is this time right here? How much time does it take her to go from 71.5 meter per second to a velocity of 0 over a distance of 250 meters? Now there's one equation, and this is not the only way to do it, but if you want to do this calculation in one step, the equation that will allow you to do it is this one. Okay? So what is V final for this part of the journey as she slows down? V final is 0, so we can cross that out. So T is going to be 2x over V initial. So now plug the numbers in. So the distance traveled for that part of the journey as she slows down is 250 meters, and V initial is 71.5. So this time comes out to be, it's 6.99. I think it's safe to round, we can just round that to 7. Okay, so we now have this time, 7 seconds. Okay, so now let's find T2. how long does it take her to accelerate out of her rest stop? So she starts with an initial velocity of 0, so v initial is 0, and then she ends up at 71.5 meters per second again, over a distance of 350 meters. So we can use this exact same equation right here. Only instead of v initial, it's v final. You know what, I'll just show it again. So using the same equation, x equals 1/2 vf plus v initial times t. What's v initial? 0. So t is going to be 2x over v final. So now it's 2, so the distance she travels is 350 meters. And then v final is 71.5. So this gives a time of 9.8. So now we have T1 and T2. So T2 is 9.8 seconds. So what's the total time? So focusing on car 1, what's the total time from here over to here? 21.8. Yeah, well, I'm trying to trick you right now. Is it going to be 9.8 plus 7? Nope, because you got to factor in the what? The rest stop. So there's 3 times that you're going to add up. You're going to add up the 7 seconds, the 5 seconds, and the 9.8 for a grand total time of about 21.8. So we're almost done now. So we now know how much time went by. So now that we know how much time went by, so now that we figured out the time, now we focus on car 1 and we solve for the total distance that car 1 traveled during the 21.8 seconds. So to do that, x equals 1/2 at squared plus v initial times t. What's the acceleration for car 1? 0. I didn't write that down, but how do we know that the acceleration for car 1 is 0? Constant velocity. Whenever you see the words constant velocity, let's see, where is it right here? Does it say constant velocity? Right here? Yeah, right here. Constant speed. Okay, constant speed is the same thing as 0 acceleration. Okay, so we're left with x equals v times t. And by the way, what is this equation here? That comes from what? It comes from the definition of velocity. You know, velocity is displacement over time. But here we're solving for x. So x is going to be her velocity, 71.5 meter per second, times the total time that went by. So the seconds cancel, and we get 1,558.7. So how far ahead will car 1 be? So we're going to go 1,558.7, subtract away 600, 250 plus 350, those two added together is 600, and then that gives us the answer. So 958.7 meters. Car number 1 will be 958.7 meters ahead.